And the last problem on our list was 76. Also not very complicated. We have several forces acting on the suitcase, and we know that the suitcase is moving at a constant speed, meaning that forces are balanced out. There's no acceleration whatsoever. We need to draw the free body diagram for the suitcase. So I'm just going to use a little dot. The suitcase has 20 kilograms of mass, so as opposed to all the other ones, they want us to calculate it, but that's easy enough. You do 9.8 times, well, 9.81 times 20, and that gives you force of gravity downwards. Then the lady pulls on the strap with a 35 Newton force at an unknown angle, but whatever, we know it's 35. I'm going to draw it like that, 35. And that 35 has two components. And I know that the force of friction to the left, so this is force of friction, this is force of pull, 35 newtons, and let me increase this so you can see it better. So then I also need the normal force in order to be able to balance everything out. So notice that normal force is going to be one box shorter than my force of gravity because of this one box. So this is my force of pull Y, and this is my normal force. And in order for all the forces to be balanced on my suitcase, force of gravity should be equal to force normal plus force of pull Y. And then horizontally, I know that force of pull X should be equal and opposite to force of friction, which is 20 newtons. So they gave me force of friction, and therefore they gave me force of pull X. Then I can easily find alpha as inverse cosine, because I know that this is 20, and that's the adjacent, and that's my angle right there. So I'm going to do inverse cosine of 20 over 35. Boo boo. That's the answer to the angle question. It amounts to 55.2 degrees if they want us to keep 3 sig figs. So that answers the question regarding the angle. That's question B. Question A already finished. And then what is the magnitude of the normal force that the ground exerts on the suitcase? So again, force normal plus force of pull Y. And force of pull Y we're going to find as force of pull Y equals, she is applying 35 newtons. The angle is 55.2, so it's going to be sine of 55.2 degrees. You could have also done Pythag. You could have done 35 squared minus 20 squared. I'm going to do both just to make sure that it's the same. What do you know? It is the same. Yay! Everything is correct. So that gets me the pull Y. And so then to find the normal force, I'm going to reach for this equation. Forces balance each other out. So then your force normal is going to be 20, which is mass of the suitcase, times 9.81 time, and then subtracted 28.7. So this right here is force of gravity. This right here is force of pull Y. So if you do 20 times 9.81 minus 28.7, you end up with 167.5 newtons. If we are to stick to just 3 sig figs, it's about 168 newtons. That's your answer for the normal force on the suitcase. That's it for problem number 76.